Welcome, NutritionRadio.org listeners. This is Lonnie Lowry, a university nutrition professor of over 20 years and podcast host of long-running shows like Iron Radio. Come on in. Market news from the food world. Hey everybody, Dr. L here again. Today we are going to look at some food science as we are wont to do in this little theme that we have going on the podcast. By the way, the podcast, slow growth, but definitely there. We've gone from just dozens into hundreds, even heading toward low thousands. That's good, but it always helps to leave comments on YouTube, even though that's just the backup, or definitely reviews on iTunes. Subscribe, of course, on these different channels, including Spotify, wherever you like to do it, Audible, Amazon. In any case, let's get back to this. I promise I won't go on about this much more unless there's something really dramatic that hits the news waves. This is more cultured meat stuff. It's just a rapidly developing industry, and this one's actually not about the protein part. So we'll look at the science journalism, then we'll take a light dive into the actual research paper. I think that's important when we can. Here's the piece that was promulgated through Science Daily from the journal eLife, it looks like. Lab-grown fat could give cultured meat real flavor and texture. This is April of this year, so spanking new. Researchers have successfully bulk-produced fat tissue in the lab that has a similar texture and makeup to naturally occurring fats from animals. We know that cultivated meats have been making waves in the news recently: chicken, beef, pork, fish. Most of the companies, not ready for large-scale production or approved for commercial sale in the U.S., but they are working on it. And one of the things they're working on is this idea of texture. What's often lacking, and I've kind of joked before about just having, random clumped muscle cells in a dish with some coloring like red Jell-O or something, not appealing. The texture is from muscle fibers, connective tissue, and fat. And it's the fat that gives meat its species-specific flavor. Isn't that interesting? In fact, if you're just going after flavor, and I know not always, health-conscious fitness people do this necessarily, but if you're just going for flavor, consumer testing with natural beef with different levels of fat showed that the highest scores registered for beef containing 36% fat. Wow, that's pretty high. But you can see why researchers are interested in this. To try to move in this direction, researchers grew fat cells from mice and pigs, first in a flat two-dimensional layer. Then they harvested those cells and aggregated them into a three-dimensional mass with a binder like alginate or MTG. Now, the article doesn't really explain. This is meat glue. Doesn't sound very appealing per se, but neither does microbial transglutaminase. Sounds just like a random sort of chemical. But they have to have something to stick these cells together, right? The muscle cells, of course, are the source of the proteins. John Yuen, the first author at Tufts University Center for Cellular Architecture. What an interesting department that is, cellular architecture. It says this can work when creating the tissue solely for food, since there's no requirement to keep the cells alive once we gather the fat into bulk. These aggregated fat cells immediately, apparently, had the appearance of actual fat tissue. Now, beyond appearance, they can also do pressure testing and things of that nature. They found the cells bound with sodium alginate was able to withstand a similar amount of pressure to fat from livestock and poultry, but the cells grown in the fat with the meat glue, it behaved more like rendered fat, like a lard or a tallow. So they're looking at this as an option, a possibility that they can actually fine-tune the texture depending on the food item. Now, here's where it gets a little interesting and even weird for me as a nutritionist and a physiologist. Cell-grown fat has a mix of fatty acids, as you might guess, different types of length and saturation points on these fatty acids. And again, remember, this is giving meat different flavor, for example, but it's also different nutritionally. Some fats are inflammatory, some are anti-inflammatory. That's why often we're interested in fish oils and things of that nature. Anyway, the mix of fatty acids from cultured mouse fat differed from native mouse fat. Now, we don't eat mouse steaks typically, so maybe that's not a big deal. It says the cultured pig fat had much closer fatty acid profile to the native pig tissue. Now, we are eating bacon and things of that nature, at least as a treat, so that's good news. The ability to fine-tune the fatty nutrition, and fats really are important, as well as the texture, means it's putting it in the hands of food technologists. Now, you may like that or not like that they can custom tailor, they can fine tune the meat to have the fatty acids that we want, keeping in mind that they affect the flavor, right, and other aspects. But it does say the research team suggests it might be possible to supplement the growing fat cells with specific lipids. They used soybean oil, which is a real mix of fatty acids. There's some omega-3, there's lots of omega-6, just quite a mix of things. And that's what they did, this mix of fat, again, to fine-tune the lipids that were incorporated into the fatty tissue that they're trying to get to sort of conglomerate together in this large-scale production of cultured fat in these bioreactors. It's just amazing to me that we're kind of taking this step away from the farm and into these huge, almost brewery-like scenes with these giant vats and bioreactors. But let's take a look at the actual scientific paper. This is from eLife. Aggregating in vitro grown adipocytes, so in a dish or in a vat grown fat cells, to produce macro-scale cell-cultured fat tissue with tunable lipid compositions for food applications. That's what caught my eye as a nutritionist. Tunable lipid applications. Very interesting. Again, this is YUEN, John Yuen and colleagues here. Here's the abstract, just quick highlights. We present a method of producing bulk cell-cultured fat tissue for food applications. Bulk fat is produced by mechanically harvesting and aggregating the lipid-filled adipocytes, fat cells, right, into 3D constructs using alginate or transglutaminase binders. Thank you, transglutaminase. I don't think I saw that in the reporting. And by the way, alginate is just a polysaccharide, it's a carbohydrate. It's found in brown algae. You could just look this up on Wikipedia if you want. It's a kind of chemical that tends to form this viscous gum when hydrated. And actually, with metals around, such as sodium or calcium, the salts are known as the alginates. It ranges in color from yellowish brown to white. Anyway, you get the idea. Something to hold the cells together. Their conclusion, again from the science paper itself, is that the mechanical properties were based on the binder of choice and the changes in the fatty acid composition, right, of the triglycerides and the phospholipids that are part of the fat, the fatty tissue, were observed after lipid supplementation with soybean oil in the culture, in the cell culture. There's a ton more information in this particular science article, which you could go read. It's an open access kind of thing from eLife. I like that kind of journal. But anyway, there's something for our food markets. The cultured meat industry is creating fat to go with the muscle cells and put it all together in a structure that has the mouthfeel and the taste of meat, but can also have, a little bit of extra omega-3s in there if you want it, or tailored fat composition, nutritional composition. Very cool stuff, and we'll keep a loose eye on where this industry goes. Thanks for tuning in. We'll see you next time. The NutritionRadio.org podcast is for informational purposes only. If you're interested in starting a diet or exercise program, check with your physician, nutritionist, or qualified exercise physiologist in order to make the progress that you need.